Meaning of @class method and @static method for beginner. What do @class method and @static method mean in Python, and how are they different? When should I use them, why should I use them, and how should I use them? As far as I understand, @class method tells a class that it's a method which should be inherited into subclasses, or something. However, what's the point of that? Why not just define the class method without adding @class method or @static method or any definitions?
Though class method and static method are quite similar, there's a slight difference in usage for both entities. Class method must have a reference to a class object as the first parameter, whereas static method can have no parameters at all. Example: explanation. Let's assume an example of a class dealing with date information. This will be our boilerplate. This class obviously could be used to store information about certain dates, without time zone information. Let's assume all dates are presented in UTC. Here we have _init_, a typical initializer of Python class instances, which receives arguments as a typical instance method, having the first non-optional argument, self, that holds a reference to a newly created instance. Class method. We have some tasks that can be nicely done using class methods. Let's assume that we want to create a lot of date class instances having date information coming from an outer source encoded as a string with format ddmei. Suppose we have to do this in different places in the source code of our project. So what we must do here is parse a string to receive day, month and year as 3 integer variables or a 3-item tuple consisting of that variable. Instantiate date by passing those values to the initialization call. This will look like. For this purpose, C++ can implement such a feature with overloading, but Python lacks this overloading. Instead, we can use class method. Let's create another constructor. Let's look more carefully at the above implementation and review what advantages we have here. We've implemented date string parsing in one place and it's reusable now. Encapsulation works fine here. If you think that you could implement string parsing as a single function elsewhere, this solution fits the OOP paradigm far better. CLS is the class itself, not an instance of the class. It's pretty cool because if we inherit our date class, all children will have from _string defined also. Static method. What about static method? It's pretty similar to class method but doesn't take any obligatory parameters, like a class method or instance method does. Let's look at the next use case. We have a date string that we want to validate somehow. This task is also logically bound to the date class we've used so far, but doesn't require instantiation of it. Here's where static method can be useful. Let's look at the next piece of code. So, as we can see from usage of static method, we don't have any access to what the class is. It's basically just a function, called syntactically like a method, but without access to the object and its internals, fields and other methods, which class method does have.
Rostislav Zunko's answer is very appropriate. I thought I could highlight one other reason you should choose at class method over at static method when you are creating an additional constructor. In the example, Rostislav used the at class method from _string as a factory to create date objects from otherwise unacceptable parameters. The same can be done with at static method as is shown in the code below. Thus both new_year and millennium_new_year are instances of the date class. But, if you observe closely, the factory process is hard-coded to create date objects no matter what. What this means is that even if the date class is subclassed, the subclasses will still create plain date objects, without any properties of the subclass. See that in the example below. Datetime 2 is not an instance of datetime? WTF? Well, that's because of the @static method decorator used. In most cases, this is undesired. If what you want is a factory method that is aware of the class that called it, then @class method is what you need. Rewriting date.millennium as, that's the only part of the above code that changes. Ensures that the class is not hard-coded but rather learnt. CLS can be any subclass. The resulting object will rightly be an instance of CLS. Let's test that out. The reason is, as you know by now, that @class method was used instead of @static method.
Class method means, when this method is called, we pass the class as the first argument instead of the instance of that class, as we normally do with methods. This means you can use a class and its properties inside that method rather than a particular instance. @static method means, when this method is called, we don't pass an instance of the class to it, as we normally do with methods. This means you can put a function inside a class but you can't access the instance of that class. This is useful when your method does not use the instance.
When to use each. @static method function is nothing more than a function defined inside a class. It is callable without instantiating the class first. Its definition is immutable via inheritance. Python does not have to instantiate a bound method for object. It eases the readability of the code. Seeing @static method, we know that the method does not depend on the state of object itself. @class method function also callable without instantiating the class, but its definition follows subclass, not parent class, via inheritance, can be overridden by subclass. That's because the first argument for @class method function must always be CLS, class. Factory methods, that are used to create an instance for a class using for example some sort of pre-processing. Static methods calling static methods. If you split a static methods in several static methods, you shouldn't hard-code the class name but use class methods. Here is good link to this topic.